All right, so for the seniors here and for the sophomores, juniors that are in the PSAT, we're going to do a quick little, hey, what's 2-7 about, even though we did an example yesterday. Hopefully you guys got these notes or are getting them into your notes. I'm not going to take time right now. The seniors already wrote it down, so just pause the video if you still need to write them down. But let me draw your attention to a few things. Okay, here we go. Main idea is we want to use a table, but we have to know what to put in the table. So what to put in the table, how to mark the intervals, which you guys see in the example, or you saw in the example that we did yesterday, how we split up the domains, or how we split up the x's. We're all depending on these two numbers right here, the -2 and 3. Technically, so the domain of this guy, the polynomial, is -infinity to infinity. So there's my beginning, there's my end, my intervals, the beginning and then the end. And then we were like through a number line, if that kind of helps, like through the x-axis. We were moving from -infinity all the way up until the first key number is what I call them, and in this problem that was -2. So that was my first interval, -infinity to -2. Then from -2 to the next key number, which is 3. And then from 3 to infinity. So I use my key numbers to split up intervals. So back here, key numbers. We have to talk about what are the key numbers for polynomials versus rationals. Remember the whole chapter, polynomials and rational functions. This was sections 2.1, that was quadratics, all the way to 2.5. Most of the chapter, like the sections, were polynomials. Then section 2.6 was rational, and 2.7 is kind of putting them all together with inequalities now, not just equals. So key numbers for polynomials. Long story short, if I were you guys, I would circle, highlight, make a big point of the zeros. They're the zeros of the polynomial, which means that we need to get our polynomial, if it helps, we need to get our polynomial for key numbers. We need to get it or set it equal to 0. So we need to get 0 on one side, and we're going to find all the zeros by factoring. Factor, 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 factor. Rational inequalities are a little bit different because they're the ones that have the top and the bottom. F of x over g of x. And we also need to get them equal to 0. So if they're not equal to 0, well, okay, hold on. The problem's not going to have equals. The problem's going to have greater than or less than. Less than or equal to, greater than or equal to. But we're going to change and write them equal to 0. So we might need to rearrange once again just a little bit. But if we can get a fraction with 0 on one side, for rational functions, all that changes is we're looking for zeros and undefines. The undefines are going to show up in the domain problems. But here's a shortcut. You can actually look at the fraction and put a little pitchfork and say, I care about the zeros of the top and the zeros of the bottom, if that helps. I care about setting the top equal to 0 and the bottom equal to 0. If I set the top equal to 0, so my f of x, those are going to be my zeros. If I set the bottom equal to 0, those are going to be my undefines, aka my DNEs, aka my domain restrictions, because it's denominator. So then over here, steps to solving, find all the key numbers. Do I have polynomials, so I'm just looking for the zeros? Or do I have a rational function, so I'm looking for the zeros and the DNEs, or the undefines? Figure out what kind of function you have, find all the key numbers, make a sign chart with intervals, pick a test value, which we're kind of used to doing for graphing, and then ask yourself, true or false, when you plug into the inequality. So that's what we did yesterday. Remember, I didn't let you guys take notes. I just had you look at the example as I solved it. Let's go ahead and zoom in on him and see if the steps make sense as to what you're supposed to do. I'm going to kind of make it a little bit bigger for you guys here in class. Very first thing I did was to look at the function and ask myself, polynomial or rational? You guys see it's a polynomial, right? No denominator. So as I look at this function, as I see it's a polynomial, I think about my key numbers being zeros. So I go ahead and just factor my polynomial. I find my zeros, which are right here. As we already talked about, I made my intervals using those zeros, splitting my number line up. And then where did each of these come from, guys? Was there anything magical about the -3, the 0, and the 4? Yeah, they're just test numbers. Anything. I just needed anything. Could I have plugged in like 1.1? Sure, for this interval. It wouldn't have worked in that one or that one, but I could have plugged in 1 point something or -1, but 0 is easy, so I plugged him in. But I didn't get to show my work yesterday. I did for this guy. What we're doing for the true and false, as I kind of showed with the arrow yesterday, is we're coming all the way back, which we could go to this one, but it's a little harder to start squaring numbers. It's a little easier usually to plug it into the factored form. And so what I did yesterday at the very end, and then these ones I kind of cheated because I knew what the answer was. I do that sometimes. But what I did is I went back, plugged in, and asked myself true or false. So for this first one, when you plug in -3 to this function, -6, -3 plus 2, -1, it was not less than 0. 6 was not less than 0. If I plugged in 0, I would get -3 times 2 less than 0, which is true. But if I plugged in 4, that would be 1 times 6, which is also not less than 0. So the false ones I ignore, the true ones I keep, and I say, hey, it's my answer. Dun, 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 dun. But we didn't get to do an example of a rational function. Let me give you guys a second to write down this equation. Or I should say, it's not an equation, it's an inequality. So this inequality. And we're going to do the exact same process, just a couple things might change because A, it's a rational function. There's a top, there's a bottom, numerator, denominator, f over a g. It's a rational function, and there's not a 0 on one side. So two things are going to change. A, it's a rational function, and B, there's not a 0 on the other side. Two things are going to change. We did put this little hint down in our notes about the pitchforks, that the top equal to 0, bottom equal to 0. But the problem is that doesn't work if we don't have a 0 already. So the struggle is we actually need to get rid of this 3, technically. So I'm going to add a -3 on this side so that that cancels out to 0. I'm going to add a -3 on this side. But here's the struggle. As soon as I add the -3, I'm good because now I have a 0 on this side. Remember, I'm setting equal to 0, thinking about my key numbers. We'll come back to the inequality in just a second. The struggle is I no longer just have a top and a bottom. I no longer have an f and a g because I have this extra -3 guy. So to make it all ready for my pitchfork or ready for my setting the top and the bottom equal to 0, I need to make it one fraction. Can you guys tell what I'm getting ready to do? If I need to get the fractions together. Grouping would work if it was factoring. How do I get two fractions together that don't have like denominators? Make them common. I have to get him to have the same denominator as that guy. No, I'm going to be really careful with my distribution or else I'm going to make some mistakes. But if I distribute, now this piece has an x minus 5 denominator and that piece has an x minus 5 denominator. I can go ahead and combine them. If you want during this process, you could keep the less than or equal to in there because we're just rewriting the original guy. But eventually with key numbers, we're going to think about it as an equals instead for just a little bit. For sake of time, did you guys already simplify up here? I think we're going to have a -3x plus 2x, which is a negative x. And then we're going to have a positive 15 minus 7, which is going to be 8. Normally I'd say this is super dangerous. I'm just trying to save on space a little bit. But that's why I'm about to write -x plus 8. Does that look right to you guys? -3x plus 2, -x. 15 minus 7. Good. Okay, now I have my function. Now I can do what we call our pitchfork, if that's an easy way to remember. For rational functions, we look at the top and the bottom. We're going to treat it like an equals 0. Technically, domain x can't be 5. If we want to be super specific, which we don't need to be, there's a vertical asymptote there because it's non-removable. It doesn't reduce. But that's going to be my undefined point, and that would happen if I set the bottom equal to 0. X minus 5 equals 0. gets me to x equals positive 5. That's my D&E point. The top equal to 0, negative x plus 8. Don't we just need x to equal 8? Yeah. That's my 0. So you guys tell me, what do we do with those numbers now that we have them, 8 and 5? Good. So Joe, you're going to the table, right? Okay. Let me get it set up. There's the intervals. Then we need our test x. And then we're asking ourselves just true, false, because we're not graphing right now. Now, tell me what you were telling me. Negative infinity to, what would be the first one? Good. And then, good. And then, got it. Does that make sense, Chris and Ariman? Good? Okay. For right now, I'm just going to put little parentheses. Well, the infinities we can never hit, so I'm going to go ahead and put parentheses around the infinities. Let's go ahead and deal with something right now as far as our grouping symbols. Parentheses or brackets. Now, when we're graphing, we always put parentheses because we always need something in between. And we're still going to pick a test x in between. But I want you guys just for a second, before we start trying to pick test values and figure out true or false, I want you to zoom in real quick on what inequality we're dealing with right now. What do we have on this problem? Which means, can the 0 be included and still make this true? Yeah. As soon as we start testing in between, we're going to be ignoring the endpoints meaning the 5 and the 8. So I want us, before we start testing in between, let's test the actual key numbers themselves. Excuse me, with this one, less than or equal to, I'm actually going to need to include the 8 because it's allowed to be included. It's a 0, and I'm allowed to have this expression equals 0, less than or equal to. But here's a question. Does that mean that the 5 gets a bracket too? Good. Why not? Well, he's not a 0. He's an undefined. Oh, x isn't allowed to be him anyway. Oh, okay, no matter what. It doesn't matter what the inequality would be. The 5 has to be excluded because it's an undefined point. So the 5, no way, Jose. He's not in the answer no matter what. But the 8, well, he's a 0. So if this was a less than, he would not be included. But since it's a less than or equal to, he is included. That's a little way just to be ready for the answer when it comes. But now we can go ahead and pick test points. So you guys, what's an easy number to plug in between negative infinity and 5? Yeah, that's what I thought. How about this one? Yeah. And then, good. Just has to be something in between. So why don't you guys take a second? Plug in. Now, you could plug in 2 different places. You could plug in here, the original problem, or you could plug in here. It needs to work in either one. If it works in one, it'll work in the other. If it works in the other, it should work in the one. I kind of usually like plugging it into this one because it's easier. But some of you might be paranoid that maybe you simplified wrong, so maybe you'd want to plug into the original. But take a second, plug in, asking yourself true or false. And based on the trues and falses, what do you think the final answer would be? Just take a second. Because when I do it, I'll do it fast. This is what I got. What do you guys think? Is any negative number for the first one less than 0? Yeah, so since that one's a check, I'm going to put true. That's a part of my answer. Is 2 less than or equal to 0? No, that's false. So forget that interval. And then is negative 2/5 less than or equal to 0? So my final answer, for what x values is that expression true? X is within the interval. Just steal the intervals, and those are your final answers. You can separate with a comma, with the word and, with the word or. Oh, no. The 8 is allowed to be included because it's a 0. And then that's our final answer. I didn't box it, but then we're done. I thought we would need that secondary page, but we actually don't. I had it ready to go if we did need it. We actually ended up just being fine without it. Let me get rid of that. I was going to show you one other example real quick, because the book, I don't think we have any of these on the test. But the book does ask you to think about this idea of less than or equal to, greater than or equal to with a graph. So I'm showing you the graph really quickly of this guy, which you could do just by hand. That's true. But another way to answer this question, when are the y's less than or equal to 0, is to interpret graphically. Well, the y's are the heights, right? The up and downs. So if they're saying when are the heights less than or equal to 0, when would that happen on the graph? When the y is at 0 or below? When the y is at 0 or below. So actually, on a graph, you could have just asked yourself the question, when is it below or on the x-axis? That's another way of looking at it, like with Word. So then you could technically, like if you were allowed to use your graphing calculator, like in homework, if they were to ask you to use your grapher, you could find the zeros and say, oh, hey, for what values of x? Think about the number line. From negative infinity up until, I think it hits at -1. Why am I putting a bracket at -1? That's a problem? Good, because it's a 0 and it's allowed to be included. And then I would have to say, nope, now it goes above, so the y's aren't less than or equal to 0. But then right here at, I think it's 3, same reason I'm putting a bracket at 3, it's a 0. So you can actually use a graph to answer too, if they give you a graph, and not even need to do all the by hand work. So, long story short, whether you have polynomials, which have only zeros as key numbers, or whether you have a rational function, which, okay, this one was nasty because there was no 0 yet. We had to move to get 0, then we were allowed to look for 0 undefined points, put them in our intervals. But either way, we're getting to a sign chart, testing and saying true or false, but we have to find the key numbers first. So that's what's going on with notes saying, this is the process, get the key numbers, make the table test. And by the way, key numbers, zeros for polynomials, zeros and undefineds for rational functions. And with that, kiddos, section 2.7 homework. So let me just go ahead and get the assignments up on the board. Does anybody need 2.6 assignment? Has everybody started? At least, okay. So let me pull up 2.7 in the review, because some of you guys maybe started the review, not review. Some of you might have started 2.7 already, so if so, you can write down the review. And if you haven't started 2.7 yet, let me get that up here. I have more than enough books over here on the side if you need to come borrow a book. Let's just have a work period. If you guys get stuck on something, let me know. You can get out your phone if you want to get into Google Classroom. If you finish an assignment, you want to post it. If you want to, there's like an app for Calc Chat, I think. An app for Calc Chat. You want to either get the app or access the app. Or if you have data, you can go online. Well, either one uses data, but you can go on Calc Chat and check too, if you're grading your homework or the odds. But underclassmen, hope PSAT went well. Hopefully that's enough to help you guys bust out that section 2.7. It's not too bad. It really isn't too bad. I think there's a long answer on the test from section 2.7, maybe a multiple choice too. So work on that homework and come tomorrow with questions.